Hello, today we're doing section 1, page 2, exam 2. These are derivatives for this section. So the derivative of x. So first, we want to start off with, since x is a variable and there's no other constants in front of it, it's going to be 1. So the derivative of x to the power 2, I'll make this clear. We bring the x down, and we subtract the top by 1. This is just the power row. These are both the power rows. Derivative of that is minus 1. Bring that down. This is just going to be x power 0. And as you know, x to the power 0 is 0. Is 1. So we're going to do 1 times 1, which equals 1. Just to explain this a little more. So working on the question 2, we're going to derive it. So 2 minus 1 is going to be x 1. You could just leave x as, you don't need to kind of indicate that it's 1, but just so you don't mess up or anything like that. And we bring down the 2. So it's just gonna be 2x. Make that a little better. Moving on, question 3. We're finding the derivative to e to the x. This one may seem tricky, but e is a constant and it's a power row. It's being powered by a variable. To kind of understand this more, you could do y equals ex. Since we're trying to derive it, we're going to natural log it. So I'll put an arrow here, natural log y equals natural log e to the x. And we're doing this to bring down the x. So we're going to work over here. Natural log equals x natural log e. We just bring down the x. And then now we're going to derive it. So we get 1 over y times dy over dx equals 1 times, which is going to be 1 times 1, because the natural log of e is going to be 1, plus the constant x. And since this is a constant, so first we're doing the product row here. So the derivative of x is 1 times the natural log e, which is just 1, plus x times the derivative of natural log e. And since we already know this is going to be a constant, it's going to be 0. So keep in mind on this. So this is going to be 1 over y times dy over dx equals 1. Since we're trying to find the derivative of e to the x, we're going to multiply y on the left side times y. And this y is important because we're going to realize that this 1 times y, knowing that y equals e to the x, is just going to be e to the x. So I'm going to erase this all and put e to the x on the answer. Moving on, we're going to the natural log of x. So the natural log of x is going to be 1 over x. This is the case because in the graph of natural log x, you have a graph that goes like that. And if you derive this, you could see that the slope is like decreasing along the x-axis. So this means that the other graph is going to go down like that. you could tell from the bottom that this is increasing at a very high rate. This is the derivative on top. It's at a high rate, and then it goes down, and then it kind of decreases until it's constantly zero. And the graph of ln x is it increases, then it decreases until it kind of flatlines. So that's the reason why it's L of x. And I'm kind of missing because the graph of 1 over x is discontinuity at 0 because 1 over 0 does not exist. For derivative of 101, you can derive a constant, but it's going to be 0 because there's no variable. For the derivative of a square root of x, square root of x equals to x 1 over 2. You bring down the 2. So yeah, x to the power of 1 over 2. The 2 kind of is the square root, and 1 is the amplifier of x, or the power of x. So this, we could do what we did for the power rule. We do 2 over 2 just to keep it simple. And we bring down the 1 over 2. As you could tell, the 1 over 2 is going to make it into a fraction. So let's just start with the fraction 1 over 2. This is going to be, or not, it doesn't mean it's going to be a fraction. It depends on what the x power is. So since 1 over 2 minus 2 over 2 is negative 1 over 2, as you could tell, this is actually going to make the x a square root, but it's going to be a fraction because when your power is negative, it's going to become a fraction. So this is going to be square root of x. I'm going to erase this now and just put the answer here so we don't have too much mess. The same thing goes for down here. X is going to be negative 1. If you subtract 1 and put the negative down here, you're going to get x negative 2, negative 1, which is just equal to, as up to here, you could tell, it's going to be 1 over x root 2 from the negative 2, and the negative 1 is going to make it negative. Okay, on the next question, we have the derivative of 4 to the power x. Like we did for the the EA of x, we're going to start with ln y, just to skip steps that we already know. Ln of y equals x ln of 4. And then I'm going to go over this real fast. So originally we have like y equals, put this over here, y equals 4x, we ln it. This is all going to be the same. It's just like a shortcut, but let's put this. So ln of 4x, this is going to make it ln of y equals x ln of 4, as we have over here. Next, we're going to derive it. So we have 1 over y dy over dx equals the product rule. So first we're going to have 1 times ln of 4 plus x times 0. Because this is a constant, this is going to be your u and v, just to break it up a little bit. So when we put this in, we have 1 over y dy over dx equals ln over 4. I'm going to clear up some space. As you can see, we're looking for dy over dx equals ln of 4 times y, because we're multiplying y from the left. So this is going to be y equals 4x. So you're going to get 4 x times ln of 4. So now we're going to put that insert in the box. It's also going to be multiplied. You can put it in the front too, but it's up to you. So this one, we're also going to use a power rule here. May look complicated because of the big number, but realistically, we're just going to bring down the exponent, put the x. Negative 99 minus 1 is negative 100. And that's your answer, just the power rule there. For the bottom answer, it's pi as a constant. Some people, like a lot of people, kind of mistakes with e and pi being like a variable, but it's not. It's a number. So a number times a variable is a product, or you could put it as a product rule. So the derivative of pi is going to be 0 times x plus the derivative of x, which is 1 times pi, and you're left with just pi. You pretty much take out the x and put a 1 in front of it. Moving on to the top of the questions, it's sine x derivative. I don't know if you can see it through the arrow, but there's a trick. So sine is going to be derived cosine, and the cosine is going to be derived to a negative cosine. The negative cosine is going to cosine, negative cosine, and the derivative of negative cosine will be sine. And the same thing going in the integral, so you go backwards, however, instead of forward like the derivatives. But this is just something to remember. So derivative of sine, as we've seen, is cosine x. And this is explained through the graphs, like sine, kind of see it like that, and then the cosine is the opposite because of the derivative. But same with the cosine, this is going to be a negative sign, as explained through the cycle. And the tangent, I like to break it up. So we're going to have sine over cosine x, don't forget the x. And we're going to do the high D low row on this. So high D low is, let's do it, equals derivative. It's going to be low to low D high. You're going to be multiplying the derivative of the top. So it's going to be cosine minus, so it's going to be high D low minus low D high, high D low. And the derivative of cosine is going to be negative sign. Let me move this real quick. So we know that cosine is going to be multiplied by itself, so it's going to be squared minus sine x squared because of the 9 signs. So since we have this, we know that it's going to be negative 1. This is just a trig right here. When you add both of them squared, it's going to be negative 1. So we get negative 1 over cosine squared. Oh yeah, and this is going to be over cosine squared. There's a little song to this. You could do low D high minus high D low over the square of what's below. So after we get that, we get negative 1 over cosine of squared. This is some trig. 1 over cosine squared x is going to be secant squared x. And even 1 over cosine x will equal secant. And this is negative from the squared cosine minus the sine squared. So we get the negative secant squared x. For the next question, we have the inverse sine. For the inverse sine, you remember these derivatives. It's not that complicated. It follows the same pattern. So sine is going to be 1 over 1 minus x squared. over the square root. It's going to be square rooted. The next one is cosine. The difference between this is -1 over square root of 1 minus x squared. As you can tell, it's the same function. The only difference is it's going to be the sign as a negative right here. The next one is tangent. The derivative of the inverse of tangent is going to be 1 over 1 plus x squared. As you can tell, there's some patterns to that. And we're gonna skip the log for now, just to kind of go on this pattern. So secant is going to be, as we said, it's going to be 1. So as said before, secant is going to be 1 over cosine x. This is going to equal, we're going to do the high d low as the same from last time. So cosine, we're going to have low d high, which is a constant, so it's going to be 0, minus high d low, which is going to be negative sign. So this is going to equal negative sine x. And I almost forgot, we're going to do this over cosine squared. So we're going to have negative sine x over cosine squared. And we could break this into pieces. So this is going to be, we're going to have tangent. We're going to have, let's do tangent first. So we're going to do negative tangent from the minus sign. So we're going to have negative tangent x. And as you can see, we're going to have, since we're taking the sine out and one cosine out, it's going to be 1 over cosine x. And doesn't mean it be negative because the negative is already down here. So this is going to be secant. And then I'm going to erase this to put on top. For cosecant, we're going to do the same thing. We're going to break it up, and then we're going to derive this. Again, we're going to do low d high plus high d low, which is minus high d low. So this is going to give us negative cosine x over sine squared. And this is going to give us cotangent, negative cotangent, and it's going to be 1 over sine, so it's going to be cosecant. And I'll put this into the top. For cotangent, we're going to break it up. As you can tell, it's beneficial to break these things up because you don't want to, overdo something that you don't need to do. So we have cosine over sine. We're going to do bottom, or low d high, which is negative sine, minus high d low, which is going to be over sine squared. We're going to put this in the log. So we know that sine is going to be squared. And then it's going to be also subtracted by cosine squared. And this is going to equal -1. So it's going to be -1 over over sine squared. And we know that this is -1 over sine squared is going to be cosecant squared. It's also going to be negative because it was -1 over sine squared. So don't forget the negative. And you always want to put the square you always want to put the square to the left side of it. You don't want to put it on the x because it will not be the same. Now we're moving on to log base 2 x. So we know that there's going to be 2y equal x just from the base form. And now we're going to derive this. So we're going to have natural log of 2, and the y is going to be behind it, equal natural log x. So now we're going to derive it. I apologize if I said we're going to derive it after this. We're going to simplify it, I meant to say. So now we're going to derive it. So we're going to do dy over dx, natural log 2. This is a product form because we know that the natural log 2 is going to be constant, so it's going to be 0. So we're going to derive dy over dx times a constant. And we can't times the derivative of a constant times y because it'll just be 0. The right side, however, let me make this a little better. We're going to have dy over dx equal 1 over x. Since we know that the dy over dx is being multiplied by natural log of squared, we're going to multiply this. No, we're going to divide it actually by natural log of 2. And I'm going to just clear up some space over here. We know that when you multiply a fraction by a fraction, they add up. So we're going to just do 1 over x natural log of 2. We did this by breaking it up, deriving the natural logs, and we also made dy over dx by itself. So that's how we do the derivatives. Thank you for watching.